Hello students, in this session we will study regarding a brief historical overview of the applications that use DBMS and how these applications provided the impetus for new types of database system. First one is regarding the early database applications. In the early database application, they were using hierarchical and network systems. Many early database applications maintained records in large organizations such as corporations, universities, hospitals, and banks. In many of these applications, there were large number of records of similar structure. For example, in a university application, similar information would be kept for each student, each course, each grade record, and so on. There were also many types of records and many interrelationships among them. Here, we can make use of hierarchical and network models, which were introduced in early mid 1960s and dominated during the 70s also. A bulk of worldwide database processing still occurs using these models, particularly the hierarchical model. The next kind of model is a relational model, and it was originally introduced in the year 1970 and was heavily researched and experimented within IBM research and several universities. Relational DBMS products emerged in the early 1980s. This, even though in current scenario also we'll be making use of relational model only, even though there are so many other models which have come after the relational model, but due to its simplicity and ease of work, many database models still we are using the relational model only. Then we have object oriented and emerging applications. Object oriented database management systems were introduced in late 1980s and early 1990s to cater the need of complex data processing in CAD and other applications. The use has not taken off much. We were thinking that due to the advancement in the technologies, we can make use of object oriented database management system in the various applications, but it did not find its much application in the various data models. Many relational DBMS have incorporated object oriented concepts, leading to a new category called object relational DBMS. Now we have new kind of DBMS, which is a combination of object oriented DBMS and relational DBMS, which we call it as OR DBMS, which has the facility of the normal relational DBMS as well as the object oriented DBMS facility is also provided in this. Extended relational systems add further capabilities. For example, it can also store multimedia files, XMLs, and other data types are also supported by this OR DBMS. Then we have data on the web and e-commerce applications. Now we can see there are a lot of e-commerce websites, right? Everyone is using a e-commerce website for purchasing all these things. Web contains data in HTML format, that is hypertext markup language, with links among pages. What we have is data is present in terms of various pages, and from one page to another there is a link, right? We'll be making use of a hyperlink. When we click on that particular link, it will navigate us to the different page. So this is how the relationship is created between the various pages. This has given rise to a new set of applications, and e-commerce is using new standards like XML. Right? In the newer version of the various e-commerce websites and all, we are making use of XML, that is extended markup language. And apart from that, script programming languages such as PHP and JavaScript allow generation of dynamic web pages that are partially generated from a database. Nowadays, we are making use of a lot of scripting languages like PHP and JavaScript, which is used for the various e-commerce applications. Then we have extending database capabilities. As I already said, due to the advancement in the technology, we can find the database application in much more broader way. First one is regarding the scientific applications. Scientific applications that store large amount of data resulting from scientific experiments in areas such as high energy physics, the mapping of the human genome, and the discovery of protein structure, wherein database find its application in scientific research. Then we have XML, as I have already said, regarding the due to the advancement in the database applications, we are making use of XML in the e-commerce websites and all. Then we have image storage and management. Storage and retrieval of images, including scanned news or personal photographs, satellite photographic images, and images from medical procedures such as X-rays and MRI tests. All these things constitute a very large storage of images which are stored in the DBMS, I mean in the database, and which we can use for further studying regarding the particular image that we have already stored in the database. Then we have regarding audio and video data management. Um, Database finds its application in storage and retrievals of videos such as movies and video clips from news or personal digital camera, wherein we are going to have a lot of audios, video files, everything can be stored and that can be managed by making use of DBMS software. Then we have data warehousing and data mining. What is data mining? Data mining is a branch wherein we have a lot of data with us, and what we do is we use that data for analyzing large amount of data to search for the occurrences of specific patterns or relationships, and for identifying unusual patterns in areas such as credit card fraud detection system. We can collect a huge quantity of data, and then we can check whether whatever the transactions that are going on, whether they are the legitimate one or whether they are the fraud one. Everything is possible because of this data mining. Then we have spatial data management. Spatial applications that store and analyze spatial locations of data such as weather information, maps used in geographical information system, and automobile navigational systems. We are using a database management system for storing the information of the various locations and for finding out where actually we are getting heavy rainfall, what is the weather condition, and a movement of vehicles. Everything is easily tracked over here. Then we have time series and historical data management. Time series applications that store information such as economic data at regular point in time, such as daily sales and monthly gross national product figures. All those things we are going to store and we are going to manage the data by considering a DBMS. Then we will see when not to use a DBMS. When we should use a DBMS, when we should not use a DBMS. There is a clear-cut information which we will be studying in this slide. Right. We know that we are making use of DBMS because we want to reduce the redundant information and we want to get the real-time information that is stored in the database, everything over there. Apart from that, there are some scenarios or some conditions wherein we should not make use of DBMS. First, we will see what are the main inhibitors, or we say that what are the cost when we make use of a DBMS. When we make use of DBMS, it has an impact like high initial investment and possible need for additional hardware. Let us assume that we were running a business wherein we were not concerned regarding a DBMS. Now, if I want to make use of DBMS in my business, then what's the first thing is I have to buy a DBMS package, right? And I have to buy some hardware which is required for maintaining this database. So high initial investment and possible need for additional hardware. Second one is overhead for providing generality, security, concurrency control, recovery and integrity functions. If I want to have security feature and if I want to have concurrency control, recovery, integrity functions, everything, then we have a overhead, that is we have to spend some money on this services. So these are the two main inhibitors for using a DBMS. Now we will see when a DBMS may be unnecessary. That is, without DBMS also we can uh, have our business done, right? First thing is, if the database and applications are simple, well defined, and not expected to change. If we consider a scenario wherein we have a database data to be stored, and which is very simple one, which is well defined, and the data is not going to be changed, then what is the use of DBMS? So DBMS is not suitable for such kind of applications. Then we have, if there are stringent real-time requirements that may not be met because of this DBMS overhead. If we consider a scenario in a real time wherein, if you make use of this DBMS, if it is not giving us the desired result, then we should not make use of this DBMS. Next thing is, if access to data by multiple users is not required. We have seen one of the advantage of having a DBMS is it allows multiple users to access the data. Now, if we consider a scenario wherein only one person is involved in this database, that is, he is interested in using it, updating, insertion of the data. If everything is done by a single person, then we don't require a DBMS. Then, when no DBMS may suffice, without DBMS also we can handle the scenario. Which are those scenario is, if the database system is not able to handle the complexity of data because of modeling limitations. If my data is such a complex that which is not handled by a database management system, then we should not make use of DBMS. And the next thing is, if the database users need special operations not supported by the DBMS. Now we know that a DBMS is used for insertion, deletion, updation, commit, revoke, all these things. These are the operations of the DBMS. Now, if we consider a scenario wherein some other work has to be done, which is not supported by a database management system, then we should not make use of DBMS. Thank you.